Welcome everyone. Today I'm excited to introduce AutoCodeAgent version 1.70, a major release packed with powerful new features designed to enhance your experience and streamline your workflows. In this release, we've integrated the OpenAI Computer Use integration tool, which mirrors the capabilities of the OpenAI Operator. This new module is built for advanced browser automation tasks, offering improved efficiency and reliability. Additionally, we've added WebSocket Integration to provide real-time updates to your front-end. This module continuously streams all reasoning steps and back-end operations, ensuring complete transparency and a more interactive user experience. Lastly, our new OpenAI Web Search Tool integration leverages the Chat Completions API to fetch up-to-date information from the web before responding to your queries, offering you the benefits of fine-tuned models combined with dynamic web search capabilities. Download the repository, the link is in the description. Run it with Docker following the instructions in the readme.md file and test its functionality. If you like it, leave a star and contribute with a fork, pull request, issue, or feedback. And if you are a programmer, come on, let's collaborate together to make an innovative project grow. So what exactly is this computer using agent by OpenAI? Imagine having a digital assistant that doesn't just answer your questions, but can also interact with your computer, clicking, typing, scrolling, and navigating just like a human would. That's exactly what this powerful tool does. In essence, the CUA tool combines OpenAI's advanced visual and cognitive capabilities to automate routine or complex tasks typically performed manually. Whether you're extracting data, filling out forms, or searching through websites, the CUA agent effortlessly takes on these tasks, saving you precious time. Now let's quickly talk about how this integration works behind the scenes. First, you provide the CUA agent with clear instructions on what you want it to achieve. Like browsing Wikipedia, searching for Elon Musk, extracting information, or even visually analyzing images on web pages. Once these instructions are set, the magic happens. The agent will start navigating your browser, performing actions step by step. It begins by interpreting your instructions and intelligently deciding the best way to carry them out. Then it performs these actions, clicking buttons, typing into fields, scrolling down pages, just like you would. After every action, it captures screenshots to understand exactly what's happening on the screen. If at any point the agent gets stuck or confused, it doesn't stop. Instead, it reaches out to you through a chat interface, clearly asking for further guidance or clarification. This continuous loop of instructions, actions, screenshots, and communication ensures your task gets completed accurately and efficiently. While this is happening, thanks to our integrated WebSocket module, you get real-time updates directly in your chat. You can literally watch each step unfold, seeing how the agent navigates websites, solves problems, and interacts with digital content in real time. This powerful interaction capability opens up endless possibilities, from automating tedious research and data entry tasks to helping you quickly analyze visual information online. And the best part, you can actually watch the agent at work through your local setup, giving you full transparency and control. If you're curious about what it's doing, you can simply open your browser to the provided local link and see everything in real time. With AutoCodeAgent's CUA integration, automating complex web tasks has never been easier or more intuitive. It's like having an incredibly smart and capable assistant right at your fingertips. Keep watching the demo video, but stay tuned. At the end, we'll dive into the integration part, where I'll walk you through how the code works and explain the main classes behind this tool. The engine.py file is central to the browsing automation system, featuring the CUA engine class that encapsulates the entire browser interaction logic. The CUA engine class constructor, init, sets up crucial components, including OpenAI's client for model interaction, Redis for asynchronous message handling, a socket interface for real-time user communication, and a screenshot manager for capturing browser snapshots. The primary method, run, employs asynchronous programming to manage browser sessions. It initiates a browser context through Browser Manager and requests an initial URL using the first URL prompt template and OpenAI's model. The method handles retries in case the URL response isn't immediately valid. After successfully obtaining the URL, it navigates to the web page and uses OpenAI's model to interpret user prompts into actionable browser commands. The method continuously processes model outputs, determining whether actions such as clicks, scrolls, or keyboard inputs should be performed, managed through the Command Executor module. If the model returns messages instead of direct actions, the system prompts users for follow-up via Redis and confirms user intent through the browser. Stop confirmation prompt. This loop continues until explicitly instructed to stop or after a timeout. Each significant step emits socket events, updating the user interface in real time. Finally, the method returns an interaction summary to the user. The Browser Manager.py file provides detailed management of browser lifecycle using the Browser Manager class with Playwright. The class constructor initializes the browser with specified command timeout settings. The asynchronous context manager methods, enter and aexit, respectively start and terminate the Playwright browser session. The create context method configures a new browser context tailored to emulate typical user browsing behavior, including viewport dimensions, device scale, CSP bypass, and a custom user agent string to evade automation detection. It explicitly overrides browser navigator properties to further mask automation footprints. The create page method initializes new browser pages within this context and sets default timeouts for subsequent browser interactions. The close browser method ensures the browser and Playwright instances close cleanly to free resources after usage. File commandexecutor.py. The commandexecutor.py file contains the handle model action asynchronous function, which interprets browser commands from OpenAI model outputs into executable browser actions. It processes several distinct command types. Click simulates mouse clicks at specified coordinates with a chosen button, left or right. Scroll moves the cursor to coordinates and scrolls the page based on provided X and Y offsets. Keypress executes keyboard commands such as enter, space, or other character inputs. Type inputs provided text sequences into the browser. Double-click performs a double-click at specified coordinates. Wait implements a short pause, useful for dynamic page loading. Each command execution logs the action and communicates real-time updates through socket events. Comprehensive exception handling captures and logs errors, ensuring robust interaction flows and stability. The prompts.py file defines precise templates guiding OpenAI's model interactions. First URL prompt explicitly instructs the model to return a singular valid URL based on the user's initial query. The URL returned must strictly conform to format guidelines, complete with HTTPS, AS, prefix, and without additional paths. Browser stop confirmation carefully assesses interactions between the assistant and the user to determine session continuation or termination. The model evaluates explicit user responses for definitive stop commands, such as stop, quit, exit, and defaults to continuation unless clear termination intent is detected. This systematic evaluation ensures precise control over browsing sessions. The Screenshot Manager.py file includes the Screenshot Manager class, specifically designed to capture visual browser states. Its capture method, executed asynchronously, captures browser screenshots, saving images locally with time-stamped file names to organize them chronologically. It converts screenshot images to base 64 encoding, facilitating easy transmission and integration into other system components, such as interaction loops and model processing pipelines. This approach provides a seamless visual tracking mechanism essential for debugging interaction validation, and user interface updates. Thank you for watching. We hope this deep dive into AutoCodeAgent's advanced capabilities has inspired you to unlock the full potential of AI-driven automation. Stay innovative and see you in the next video.